Okay, so now I'm going to talk about some studies that we did to evaluate the cost and performance of workflows in the cloud. So there was sort of two big studies and then a couple case studies that we did. The first one was, and these were all done in the context of EC2, so Amazon EC2, so a commercial cloud. The first one was a resource evaluation. This is basically the idea here was to characterize the performance of workflows running on virtualized machines, to look at all the different resource types that are provided by Amazon, and to compare them with typical grid resource. And then also to look at the cost in terms of the resource cost, transfer cost, and storage cost for the data for our typical workflow applications. We also did a storage system evaluation. So workflows, unlike tightly coupled applications like MPI codes, typically communicate by exchanging files. And in a distributed application, distributed environment, the way they do it is typically through a shared file system, a network file system. So in a HPC center, you might use the parallel file system, for example. And so one of the challenges of deploying workflows in the cloud is to replicate that. And so you can do something like NFS, which may not scale. You can deploy other parallel file systems. So, or you could use a cloud storage system like Amazon S3. So this study looked at that. And then there was two case studies on these astronomy applications. One was a long-term sort of science portal type application with a workflow in the back end, and then a periodograms workflow that was just a short term. So this is what the execution environments look like. And so like I said, we're comparing to grid. In one case, this is the TeraGrid or Exceed now. This is from a couple years ago. So in the cloud approach, the workflow management system is running on the submit site outside the cloud, and we use a Nimbus context broker to deploy this virtual cluster inside the cloud. In the grid scenario, similarly, we run the submit host outside the grid site, and then we use Corral, which is a Glidin-based pilot job provisioning tool to provision Condor pool inside a grid site. And so basically, these two environments are the same. You know, the setup is the same for both, functionally identical. These are the three applications that we looked at. So these are kind of typical applications. Montage, this is a astronomy workflow that builds these image mosaics. So this was the Montage galactic plane that I showed earlier. This is a sort of smaller version of that. This is a very IO-intensive application. Epigenome, this is bioinformatics. This is mostly CPU bound. It's doing sequence alignment. And then broadband, this is an earthquake science application. And it's sort of medium in both IO and CPU, but it has big memory requirements. So the first study we did was the resource performance evaluation. And so this was focused on just looking at the different VM types. Because say in Amazon, they provide you, a dozen different virtual machines that are configured with different amounts of memory and CPU. And we wanted to look at how do workflows perform on different ones, and is there a way to map, this is my application requirements, and this is the virtual machine I should use. We wanted to also compare the performance and cost of these different resource types, compare it between the grid and the cloud, and then characterize also the virtualization overhead to see how that impacts, what impact does virtualization have on a workflow application. And so this study uses only single instances. And in the storage system evaluation, I'll talk about the parallel case. So these are the different resource types. The last two are grid resource. This is ABE, cluster at NCSA. And there are two configurations, even though there's one cluster, because one of them uses a Lustre parallel file system and one of them uses a local disk. And the reason why we chose ABE is because its resource type, its CPU and memory and everything was very similar to the C1 extra large instance type on Amazon. So we wanted to compare and see how those two compare. So this is performance graph that shows runtime. So the primary metric for workflows is time to completion or make span. That's what people are interested in. And for different applications and different resource types. So the important things to notice here is there's a huge difference, huge variation in performance. So a lot of studies you see on Amazon EC2, they choose, maybe M1.small. And M1.small is a terrible choice, right? You wouldn't choose that one. I'll show you in a minute. The cost is bad too. But for the montage application, this remember the IO-intensive application. If you compare this, the orange and the gray, these are the two Abe ones. You can see a huge difference between running on the Lustre file system, which is the orange, and running on the local file system. But if you compare the C1.x large, which is this turquoise, with the gray, that's using local disk on Abe versus C1x large in Amazon. You can see they're approximately the same. And that's true of all of the applications, that they're really quite comparable in terms of performance. And this is because, unlike tightly coupled applications, workflows don't rely a lot on the network for communication. They're using a file system. In this case, we're using a single instance. So the impact of using the cloud on the performance of workflows is not as big. In fact, it fits pretty well. I also found, comparing these two, that the virtualization overhead was less than 10%. That's just approximate because it's not very well controlled, but this is consistent with what other people have found just comparing virtualized applications running in virtual machines to regular. And then the parallel file system was a big advantage for Abe because that, for the montage application, it allowed much faster, much better performance. So cost analysis, so this is broken down into 3 categories. So there's resource cost, that's how much you pay for the virtual machines. Transfer cost, this is how much it costs you to transfer data into and out of the cloud. And storage cost, which is the cost of both storing VM images and input data in the cloud. So this is the resource cost. In general, the cost for this level of workflow is pretty low. They're around $2 each. These aren't huge workflows, but they're pretty typical of what a scientist would like to run. M1.large was the most effective, cost-effective. It wasn't the fastest, and it wasn't the slowest. Resources with the best performance in general were not the cheapest. And then there's a big impact of this rounding. So Amazon, they round up to the nearest hour when they charge you. For this level, for workflows that are running only on the order of a couple hours, that rounding has a big impact on the final cost. Transfer costs, the main thing here is that transfer costs can be pretty high for IO-intensive applications especially. In the case of montage, the cost of transferring the output data from the workflow was as much or more than the cost of computing it. So that can be a significant problem for data-intensive applications. In terms of storage, short-term storage cost is relatively inexpensive. I'll show the case study in a minute where we looked at more long-term storage costs where it didn't work out so well.